We'll continue with exercise 7D, question 4, coordinate geometry. We have to find the value of P, given already that the points are collinear. Collinear means they lie on the same straight line. We already see in question 3, if the points are collinear, area triangle will be equal to 0. So we will make use of that fact for question number 4 and number 5. So you remember that if the lines are collinear, the area triangle will be equal to 0. So the value which you know, you replace in that area of triangle. Here we will have -1, then it will become P minus -1, 1 minus from the formula, 1 minus from the question. Then if we take 2, it will become -1 minus 3, then plus 5, then we will have 3 minus P equal to 0. This 2, since it is multiply, if we take the side, it will become 0. Then here we have -1, minus to minus, plus a number and alphabet we cannot plus, so we have to leave like that. Here both are number, we can plus, no problem, but both are minus, so we have to make the sign minus only. Number and alphabet we cannot plus, so you multiply. 5 into 3, 15. 5 into P, 5P. Aim is to find P, so P keep one side, the other transfer the other side. Okay, minus into plus, here minus to plus, minus, then minus 8 plus 15 minus 5P equal 0. Here we have P and P, both minus, so we have to plus. No number here mean 1, so 5 plus 1 will be 6P. The other we transfer the other side. Here 8 plus 1, 9, so 15 minus 9, 5, 6, 7, 8, 9. We will have it as 6. Plus here, take the side, become minus. So P equal to minus 6 by minus 6. That means value of P equal to 1. So similarly, you can do for 2, 3, even this one also. So we see the already given the point are collinear. So that means area of triangle, we can take it 0. Then you apply. So here we will have like, if you take -3, then we will get P double minus 5. Then if you take 2, it will become -5 minus 9. Then if you take 4, it will become 9 minus P. So here minus to minus, plus. One alphabet, one number, we cannot plus, leave it like that. Here both are minus, you can plus, but sign remain minus. Here one alphabet, one number, you cannot minus, so multiply this one inside. 4 into 9, 36, 4 into P, 4P. Then there also we multiply, -3. This 2 here, we can cross multiply that side, okay? So 2 into 0 will become 0. So -3 into P, -3P, -3 into 5, -15. 2 into -14 will be -28. So P and P, this one minus, there also minus. So for both minus, same sign we have to add, but sign still remain minus. Then 28 plus 15, 43, both minus. If take the side, become plus. Then this plus, take that side, become minus. So 43 minus 36, we get 7. P will be 7 divided by -7, because here between 7 and P is multiply. So that means we have to divide, we will get it -1. Then here again, we take the point are collinear, so that means we can take it equal to 0. So here we can see, if you take 3, we will get P minus 5. Then if you take 4, it will be 3 minus 2. If you take 5, it will be 2 minus P equal to 0. Then 2 as usual, you cross multiply that side. Here one number, one alphabet, we cannot minus, so multiply. 3 into p, 3 into 3. Here both number we can minus. 3 minus 2, 1, so 4 into 1, 4. Here one number, one alphabet, we cannot minus, you multiply inside. Now p we can put one side. Here we have plus, here we have minus, so you can minus. 5 minus 3 will be 2, 5 is greater, so we have minus sign. Then here 4 into 1, 4, 10 plus 4, 14, 14 minus 9. Okay, we will get 5. Plus is greater, take that side, become minus. So p equal to minus 5 by minus 2. Minus minus cancel, p equal 5 by 2. Then here also they say that the point are collinear. We have to find value of k. So the same way, we know that if the point are collinear, that means they lie in a straight line. So the area of triangle will be 0, because when the point are in straight line, they cannot make triangle. So here we use area triangle. Here we use k, it will become minus 2 minus 4. If we use 6, it become minus 4 minus 3. If we use minus 3, it will be 3 minus minus 2. Both numbers, so we can plus, but sign remain minus. Both numbers we can minus. 4 minus 3 will be 1. Then here minus to minus plus. Both number we can plus. 3 plus 2 means 5. 5 into 3 will be minus 15. K into minus 6 minus 6k, then those. K will leave one side, this 2 we minus, can take that side. Here we can divide by 3, then we get the value of k is minus 3 by 2. Then here again, that means the area of triangle will be 0 because the point are collinear. So if you take 7, it will be 1 minus 2k. If you take 5, it will be 2k minus minus 2. 1 minus from formula, 1 minus from here. Then if you take 3, it will be minus 2 minus 1. Here one alphabet, one number, we cannot minus, so into them. 7 into 1, 7 into 2. Then here minus minus plus, one number, one alphabet, we cannot plus them, so multiply. 5 into 2, 5 into 2 will be 10k and 10. Here both are minus, so we have to plus, but sign remain minus. Both are number, so we can plus. Okay, 3 into minus 3. So k and k we can put one side, the other we can transfer the other side. So 17 minus 9, it will be 8. So this is plus, take the side, become minus. So k will be minus 8 by minus 4, which is equal to 2. Then same way for number 3 also. You can try yourself. So here 8 will be minus 4 minus k. If you take 3, it will be k minus 1. If you take 2, it will be 1 minus minus 4, double. Then same way, this 2 we can cross multiply this side. Then one alphabet, one number, you cannot add them, so multiply. 8 into minus 4, 8 into k. Here also one alphabet, one number, you cannot minus, so multiply them. 2 into k, 2 into 1, minus to minus plus, both number, so you can plus. 4 plus 1, 5, 5 into 2, 10. K, this is plus, this is minus, so 8 minus 2 will be 6. 8 is greater, so minus. Minus 32 minus 2 will be minus 34. 10 plus 2 into 5 plus 10. So 1 plus 1 minus, we can minus. They are minus, take the side, become plus. So that means k will be, because here we have into, okay, between 6 and k. So you divide, k equal to minus 4. Then we see question number 6. Find the area of triangle whose vertices. The vertices are given to be this. Then we have to find the area of triangle. So same way we apply the formula, but we have to be careful because all alphabet. So if we take half base into height only, so we take half a, then it become c minus this one. Then if we take a, it will become c minus a minus c plus a. Then if we take minus a, it will become c plus a minus C. So let us see now carefully. All are alphabet, so here we into minus to plus, minus, minus to minus, plus. So here 1C and 1C, 1 plus 1 minus, we can cancel. So A into A square. So let's see from the second part. We have C minus A. So this one also we can into inside, minus to plus, minus to plus. So then we get 1C. This one we get 1C plus, 1C minus. So we can cancel. Minus A, both minus, we can plus. It will be minus 2A into A. So A into A, 2 minus 2A square. Then is the third part. Here we have C minus C. Then we are left with A. So A into minus A will be minus A square. So 1A square plus 1A square minus. We can cancel. We are left with minus 2A square. So 2 and 2 we can cancel. Remember we have modulus. So if we remove the modulus, minus also will go away. So area of triangle in this case it is A square. Then same for number 2 also. If we take this one, then it will become 282 minus 283. If we take 82 square, we become 283 minus 281. Then if we take 83 whole square, it will become 281 minus 282. Same way of doing, what we have to be careful since it is with alphabet. After we replace value, now we check. Here we have 2A, 2A. We can take common. So 2A into A will be 2A square, T1 square. Then we are left with T2 minus T3. Here also 2A, 2A. We can take common. It will be 2A square. Inside we are left with T3 minus T1. Then here also 2A, 2A common. We can take it out. It will be 2A square. Then here inside we are left with T1 minus T2. Then next step, if we check 2A square is everywhere. So we can take that one outside. So 2 cancel, we are left with A square. Then inside bracket, here we are left with T1, T2 minus T3. From here T2 square, T3 minus T1 plus T3 square, T1 minus T2. Different T we have, so let's into it inside, okay? T1, T2 square, T1, T3, T1 square T3, then T2 square T3, T2 square T1, T3 square T1, T3 square T2. So let us see if we can do anything. We can rearrange T1 square T2. We have here T2 square T1, T2 T1, T2 T1. So let's put them together. Here we have 1, 3. Okay. Then let's see with this. We'll try to take common to get same common. Okay. Then here also T3, T3 there. We'll try to see to take common. So here T1, T2, T1, T2 take common. Here there are 2 T1, so we can leave 1. Then 2 T2, 1 is outside, 1 is inside. Then here we have T3, T3. We take common, so inside we are left with T1 square minus 2 plus minus T2 square. Then here T3, T3 we can take, so we are left with T1 minus T2. Then here we can apply A square minus B square. So if we check everywhere, T1 minus 2, T1 minus T2, T1 minus T2, that we can take out. So from here we are left with T1, T2. Then this one is T3 into T1 again. It will be T1 minus to plus minus T3 into T2 again those. Then here we are left with T3 square. Okay. Here again T1, T1 we can take common. So we are left with T2, T3. Then again T3, T3 we are left with this. So here T2, T3 again they are common. T1, T3 they are common. After that we cannot do anything. Okay, so this will be the area of the triangle.